The Arrhenius equation shows the relationship between the rate constant and the temperature in Kelvin. The activation energy, EA, is an energy barrier or hump that must be surmounted for the reactants to be transformed into products. The higher the activation energy, the slower the reaction rate at a given temperature. To achieve more products, there should be a low activation energy and high temperature, which makes the negative exponent in the Arrhenius equation small, which also makes the exponential factor approach 1. Inside each test tube, I measured 10 milliliters of sodium thiosulfate solution. This solution was created with 3 grams sodium thiosulfate mixed with 97 grams distilled water to create a 3% sodium thiosulfate solution. I then added 10 milliliters of vinegar, which was a 5% acetic acid solution. When combined, they produce water, sulfur dioxide, and solid sulfur. The solid sulfur is what gives the solution a cloudy appearance. There is a cloudier appearance within the test tubes when more product is created. With increased temperature, such as with the test tube in the boiling water, the rate of reaction is much faster. We can see this through the speed at which the test tube in boiling water turns a cloudy color, indicating the production of solid sulfur, which is a product. This is due to increased kinetic energy of the molecules of solution. With increased energy, the reactant particles collide with greater force and more often per unit time. With more collisions and increased force of collision, reactant particles are more likely to collide with correct orientation and with enough force to overcome the activation energy. Increasing the temperature does not lower the activation energy. It just increases the kinetic energy of the molecules, making them more likely to overcome the activation energy and proceed towards products. In the test tube inside the ice beaker, the reactant particles have lower kinetic energy and collide less often per unit time and with less force, making it less likely for them to overcome the activation energy. We see this in the amount of time it takes for the solid sulfur to appear and the lesser amount of it compared to the beaker in boiling water.